Sharifa will let you all to each of you give some information about the something that you got or something that you have some difficulties. Yeah. Okay, Sharifa, please you start first. Then I will wait for a student to present something. Yeah.
Okay, thank you, Prof. Just Prof, what we already discussed with student, with Dr. Vitri also, that student will, one of the student will present for this time. The student is Kausa. Because the three students, they discuss together the exercise that we have given to them, and one student only present for this time.
Dr. Sharifa, can I become one of it also? So there will be two students.
So Aisyah also want to present.
Yeah.
Okay, so the first one is Kausa, and after Kausa, Aisyah will present also. So we have two students today, Prof.
Yeah. Okay. Okay. That's very good. Yeah. Okay. So please start. Who will present first? Okay. Yeah.
Kausa, are you here?
Yes. Wait. I not present.
You not share slide, yeah?
Sekejap,
Okay. Prof, this is the name of our FIP student under me and under Dr. Vitri.
That's very good. Fantastic. Yeah. Could you share, could you also send the slide presentation on chat? Then I can download. Yeah.
Okay.
You share in group. Kausa, you
Or
share in group.
in group is okay, or a chat is better because
Oh, it's chat.
yeah,
Yes.
chat is better. Yeah. Yeah, okay, I got it. I got it already. Yeah.
Okay. Does everyone see this slide?
Yes, yes.
Okay. So hi, my name is Nurul Kausawati Sapian, and my group members is Aina Sofia and Fatima Rukaya. So for the task we are given, we need to find the simple specific graph, the bijection, cardinality, and another example of graph. So first, we are assigned to choose a simple specific graph. So this is the graph that we choose, which is a lollipop graph. Is the combination of two graphs, which is cycle graph and path graph. So we label it as x1, x2, x3, y1, y2, y3, y4. So next, for the bijection, I make it into two, which is the cycle and path, because we have the same label which is 5. So I think we need to separate it between the cycle and the path. So for the cycle, I got fxi equal to I, which I is greater than equal to 1 and less than equal to 3. So for the path cycle, we get Fij equal to j plus 3, which j is greater than equal to 1 and less than equal to n. So next, for the cardinality, we find for the vertex, which is xi, where I is greater than equal to 1 and less than equal to 3, union with the yj, where j is greater than equal to 1 and less than equal to n. So for the cardinality of vertex, we get n plus 3. Next, for the edge, we get x1, x2, x1, x3, x2, x3, x1, y1, union with yj, yj plus 1, which j is greater than equal to 1 and less than equal to n minus 1. For the cardinality of the edges, we get n plus 3. So next, this is another task we are being assigned, which we need to find the cardinality of E. So we get n plus n minus 1 plus 1, which equal to 2n. So that's what we got from the task given. Thank you.
Huh? Okay, all right. Fantastic. Very good. Yeah. So please okay, please go to the second slide. Yes, this one. Yeah. Yeah, okay. So you have obtained the rainbow anti-magic coloring of this graph. In general speaking, we call this graph as a tadpole graph. Yeah. But normally also we expand the cycle until n order, and we expand the path also until n order. So didn't you think or consider for the n order of the cycle only 3 vertices? Can you expand to more than 3 vertices?
Sorry, can you repeat?
Yes. Look at this one here.
Yes.
The vertices in the cycle consists of 3 vertices.
Yes.
If you expand more than 3 vertices, or even up to order n, can you determine the rainbow anti-magic coloring? Second one, if we have path here and the right side, you already showed me that the path could be extended into an order. But what about this one? That the second question. Yeah. So what do you think? Could you give me some explanation?
I think if we expand the cycle, we also can get the rainbow graph.
Yeah, then? So what is the difficulties? Just try, yeah, just try. Probably it will be still working if you expand the cycle of tadpole graph. Yeah. Just okay.
Yes, I think it's still working.
It is working.
I'm not sure, Prof.
I'm not sure. Okay. Yeah, because if let me share to you, saya bisa nge-share nih. Okay, let me share something to you. So if you do not extend the order of the cycles, we already have it here. We already published this one in Journal of Physics. Yeah, we have for every integer n greater than equal 1, RAC of tadpole graph, yeah, of order n, but we restrict the order of the cycle only 3. Then the rainbow anti-magic connection numbers is equal n plus 2. This is already done. Yeah, it's already done. But it's okay for exercise. I really appreciate your effort. But if you can extend this one, then it will be very nice. Yeah. So your presentation is actually already good. Yeah. But to be a new lemma or theorema, actually we already cover this in the publication written of by my student HS Budi David. It is already published in the proceeding index by Scopus. Yeah. So what do you think? What do you think, Aisha? Is it your Aisha? What do you think? So, sorry,
It's
Aisha.
Kausar, Prof. Kausar.
Yeah, what do you think? Yeah, okay, what do you think? Okay, so please try, yeah, please try. Okay. Please.
Prof,
Yes, yes.
that means we need to create a new graph.
No, no, no. So what I'm thinking, the open problem here, it is exactly the same with my publication, but if she can
stay
extend,
open. Stay open.
yeah, she can extend the
Oh,
order of the cycle, and it is a new problem. It is still open. But if they use exactly the same with this graph, it's already done. We already published this one, yeah, in the Journal of Physics conferences. Yeah, this is sometimes the tricky one is find out the new solution or solving a problem that's still open a problem in the others graph. Yeah.
How about Prof, when we have these two kind of graph,
Yeah,
cycle and path.
Yeah,
cycle
definitely.
and path.
I
And
will
we
try. I will try to find out. Yeah.
We do what we call product of graph.
Yeah, actually, this is not a real product actually.
Yes.
Because you
This
only
is not real
attach,
product yet. Only
yeah,
one.
only attach only one vertex. Yeah, actually,
Yes.
yeah. So, but in some paper they call a tadpole graph. Tadpole graph, yeah. But the tadpole graph, the cycle is not fixed only in order 3, but it is extendable. So the orders can be up to order n. So if we can, in this case, you extend this one, that will be very nice. Okay. Okay. I'm thinking a way how to extend this one. Look at this one here. Can you present again your slide? Can you present again your slide? Bisa ditunjukkan lagi slide-nya? Oke, ya, oke, ya. So look at you. 1, 2, 3, 4, 5, 6, 7. Yeah. The combination of even number of vertices and odd number of vertices. So you have here 1, 2, 3, and then you have 4, 5, 6, 7. Let me draw from here. Right, I just want to draw the. So you have a path of order, even order, and you have a cycle of even odd order. Could you close the share screen? Yeah. Okay. I make it not. Yeah. Unfortunately, I couldn't download. Belum bisa nih di download. Oh yeah. Maybe because you make a slide presentation in Canva, yeah. If you can share the PDF file, maybe it's better. I couldn't download. It's okay, but hopefully I can remember what. Okay, I try to have this one. Yeah. Okay, let me show you something here. Yeah. So you have this one, yeah. And then you say x1, x2, x3. Or you can try with something bigger, but still you have 5 odd order. And in this case, you have 4. 1, 2, 3, 4. Am I right? You say 1, 2, 3, 4. And then I also can extend here 1, 2, 3, 4, 5, 6. Yeah. Let me see whether it is also working. By following the pattern that you already got it from the various one. Yeah. So what is the pattern that you have it? The pattern that you have it. Okay. You have 1 here, 2, 3. Am I right? Then 4, 5, 6, 7. What do
Yes,
you think if you say start with the same thing? 5, then 6, 7, 8, 9, 10, 11. Let me show you. Here is 5, 5, 3, and then 4. Yeah. 9, 11, 13. Then you have 3, 5, 7, 9, 6, 7, 13, 15, 17, 19. What do you think? Is it okay or not? Let me see the RC of this graph. Actually, sorry, maximum RC G, comma delta G. Yeah. Then the maximum, the RC, actually the lower bound, the best lower bound is equal with the diameter itself. The diameter of this graph 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. This one H from here, 1, 2. From this one, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. And the maximum degree is
Prof,
3.
sorry. Prof,
Yes.
sorry. Us against the 8 diameter because we couldn't see which one you show to us, the diameter, which one you count it.
The diameter is the
The,
biggest distance. The longest, the longest distance, that's the diameter. So if you see from here, diameter from x2, for example, that's we consider the longest distance. Yeah. Yeah, from x2 to y5, y4. So what is the distance? Of course, 1, 2, yeah, 3, 4, 5. Yeah. Understand? Okay, let me consider the longest distance from here to here. Yeah. Then you have 1, 2, 3, 4, 5, 6, 7, 8. Yeah. That is the lower bound, the best lower bound is equal to the diameter of the graph. Yeah. But you cannot go x3, x4, x5 because this is not the distance. Distance is the shortest part, of course. Yeah. But the longest distance is the diameter of any two vertices. Yeah. Okay. Then the degree of this graph is 3. So I can say that, yeah, sorry, the degree is 3. Yeah. So then maximum is 8. Yeah. Of course, this one, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So the lower bound of RACG is greater than equal 8. Yeah. Now consider the red number. The red numbers. How many different number there? Let me show you. 7, 1, 2, 3, 4, 5, 6. Yeah. Then 1, 2, 3, 4. Is it 10 different numbers? Just count the different numbers of the red one. 7, 13, 15, 17, 19, 21. And you have again 3, 5, 9, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10. Yeah. So the gap is actually 2. It is too much actually. If you have a gap as many as 2. Yeah, 2 more than 8. Yeah. Because 10 minus 8 is equal to. So if you have RAC rainbow, nanti magic connection number of G is 9, or if you are really lucky you can get 8, then we do not doubt about this one. But if it is 10, it is too much. It means 2 more than 2, more than 8. Yeah. Look at it in that diameter of G is 1, 2, 3, 4, 5. You have 5. And RAC, yeah, RAC of G is 6. That's very good. 1, 2, 3, 4. Yeah, this is 5, 6. Yeah. Here, diameter 1, 2, 3, 4, 5, 6, 7, 8 plus 2 is 10. Yeah. So that's why we didn't find any result if we extend, because if we extend in this manner, in this way, then we will have a bigger number of REC, which is very far away from the base lower bound, yang akhirnya jauh dari lower boundnya, sehingga ini menjadi open problem. Tetapi khusus yang ini, that's fine, this is good, ya, karena hanya ada satu lebihnya, ya, 1 more than 5, it means 6 here, ya. Understand? Bisa dipahami? Siapa yang mau bertanya? So, actually, my question, pertanyaan saya, bisa tidak menemukan 9? Instead of having hands, is the number of the different edge weight. Bisa nggak menemukan 9? Ya, sebab ini berbeda semua ini. Karena kita memutar di situ. Okay, let me try. Who knows? We can fix this problem. Yeah, we can. What? Yeah. Okay. Let me start with this one again. 1, 2, 3, 4, 5. Yeah. Instead of labeling in this way, yeah, you label in this way. Why we not try to label in this manner? 1, 2, 3, 4, 5. Yeah. Sorry, 4, 4, 5. So you have 6, 7, 6, 7, 4. Yeah, understand? Sorry. Yeah. 1, 2, 3, 4, 5. Then it goes a normal way, just like a beginning. 6, 7, 8, 9, 10, 11. Yeah. This one. Okay. Yeah. Okay. Let me now consider the H weight. Then we have 6, 7, 6, 7, 4. Then we have 7, 13, 15, 17, 19, 21. Let me show you. Probably this is working. When I have this one is x1, x2, x3, x4, x5, and then you have y1, y2, y3, y4, y5, y6. What do you think? Bisa nggak membuktikan bahwa itu benar? Coba, benar nggak ini? Benar apa tidak?
Prof. No, Prof, can you hear me?
Yes, yeah, I can hear you. Yeah.
So from my opinion, I think that it's not true or it's not exist because
Okay. Why?
there is a repeating of
Okay. There is a repetition of the H weight. Yeah. Wow. So when you start finding a rainbow path from this vertex to this vertex, then you couldn't avoid to go from 7, 6. Nah, this one is not good. Yeah, 7. There is a repetition. Understand? Yeah. Okay. Even you start from here, from x4, yeah, to y6, again, you couldn't avoid to go from 7, 4, again. Yeah, contradicts. Yeah, with 7. In fact, you should find out all paths assigned by different color. But in here, you can't make it. So this is the open problem. That's I called it. Open problem. Yeah. So for tadpole, actually, it is not finished yet. For general case of the cycle. For the specific case of the cycle, that's yes, it is already done. Then your homework is fantastic. It's very good. Yeah, because it is already shown by you. That's yeah, you have this presentation. Okay.
Prof, what
Yes.
happens? We change the level of in the cycle graph. We change the level 5 and 4, the position.
Yeah, definitely. It is a good idea. Hopefully we can get it. Then we can have a new paper then, if we can. Yeah. Okay.
Meaning that
What do you think?
for this
So
one paper, is it
again, so you change 4 with 3. So
no,
with
5 and 4.
5 and 4. So you will put 5 here, 4 here.
Where
Yeah.
12 from.
Oh, it is okay. So then I have 4 here and then I have 5 here. What do you think? So this one is 5.
Yes. And one
Okay.
6.
Oh, let me. Fantastic. 5. This is 6. Yeah.
And then
And this is 7. And this
Eight.
is 8. Oh, fantastic. Fantastic. 6, 5, 7. From this one, 8, 4, 7. Yes, you got it. Huh. That's it. You got it. Who? How bar? What do you think? How bar still here? You got it already.
Yes,
Yeah.
Prof.
Yeah. How bar? So look at, if I add 2 more vertices, and then I got 1, 2, 3, and then from here 4, 5. Then you have it. So please extend for cycle of order 7. So choose the odd one. Is it still working or not? So Kaubar already showed me if the cycle is order 3. And Aisha Jamil already showed me that you can have more vertices in the cycle. If put 2 more, then it is working. So what about 7? 7, okay, 9, okay. Then you can generalize. Then you will have one theorem about this one. And then I will check it. If I haven't determined yet, then it will be a candidate of a new theorem. That's we will have a joint paper between you and us. Yeah. What do you think, Sharifa? Are you still here?
Yes, yes. I'm
Okay.
stay here.
Okay, hopefully you get better from your paper. Ya, saya percaya mahasiswa sangat smart, sangat capable. Sudah, Aisyah? Can you find out for 7? Let me try with your way. How to-
The path graph, is it increasing the order or is still same?
Which one? The path is increase. Yes,
How
we should
many?
extend. But in this case,
Uh-huh.
please choose the odd number of vertices. Any odd number of vertices. Yeah.
Right.
Oh, sorry. Oh, even number. Sorry. 1, 2, 3, 4, 5, 6. Even number. Yeah. So you can try 8 number. Because I'm thinking it doesn't affect a lot because it is forming an arithmetic sequence of order 2. Yeah. Have you tried?
Yes, Prof.
Is it working, Aisha?
It's working.
Oh, fantastic. Yeah.
Where the same pattern of labeling.
Yeah. It should have a pattern. Otherwise, we couldn't extend. That's methods called a pattern recognition. So in a graph, we should go from a pattern. But the pattern couldn't be developed by a programming, by a coding. Yeah, as we do not know yet what is the pattern before. Unless the human being brain found the pattern, then we can copy into programming to extend the label or the colors of the graph. Yeah. Okay. Let me follow the pattern. So what is the number that you got here? For example, I got 3, yeah. And then I put 3 again. It is 6. And then I put, it is 7. Yeah. And then this is 9. What do you think? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 even. Yeah. Then we have this one. Yeah. This is should be even.
It
Should be even. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. Okay. With the same pattern, you have 1, 2, 3, 4, 5, 6, 7. Am I right? Yeah. Am I right? Then you have 8, 9. Oh, what happened? Sorry. Sorry. It is wrong. Yeah. Because it should be alternately 1, 2, 3, 4. Yeah. 5, 6, 7, 8, 9, 10, 11. Yeah. Okay. Then you got 12. Yeah. You got 13, 14, 15, 16, 17, 18, 19, 20. Yeah. What do you think? Okay. Let me calculate the H weight. 8, 9, 10, 11. What is that? 12, 13, 14, 15, 16, 17, 7. This is 13. Danger because there is the same one. Yeah. And this is again 15, danger, same one. 17, yeah, the same one. But otherwise, this one is 21. It will be what? Sorry, this one 19. Oh, what the heck? 31. Yeah. 33, 35, 37, 39, 41, 43, 45. Yeah. This one is 25, 27. So what do you think? Is it working? I have got from here the 25, 27. Is it working? Show me.
Yes, Prof, it's working, right?
It's working? I don't think so.
I think it's 3. Why?
Because we have 13 and 13.
Why don't we choose the other path, Prof? Why should we choose the 9, 11, 1?
So which one?
If we
Is it
choose path 9, 3, 8, 2, 7, 1, 12, and the rest,
Yeah, until here, you mean? So, for example, this is x1, x2, x3, x4, x5, x7. Yeah. Sorry. I just give the notation of this graph first. x1, x2, x3, yeah. x4, x5, x6, x7, x8, x9, x10, x11. Then you got y, y2, y3, y4, y5, y6, y7, y8, y9, y10, y11, y12. So you will go from here to here. Okay? Yes, okay, no problem. 12, this one, this one, this one. Done. No problem. So what about from here to that one? What? Yeah. Very good. What do you think, Aisha? Yeah.
if we use that path, yeah, that one is correct. But if we use the other path, which is x6, x7, x8, x9, x10, what's that? 11. The
From
11,
which one?
if we choose the other path, which is
Yeah,
x,
so show me the red one. Show me the red one.
The red
From,
one?
yeah, 13.
13, 14, 15, 16, 17, 7, 30, 25, and so on. That one is
Yeah, you mean 13 and 13 is conflict. It's
yeah,
the
that one.
same. Yeah, but for the rainbow connection, rainbow anti-magic coloring, we only choose one rainbow pad. If there is already exists one rainbow pad, then we do not care the other pad, even they have a similar edge width.
Mhm.
Yeah.
So the correct path that we can choose is 12, 11, 10, 9, 8,
Yes,
30.
yes, exactly. Yeah, this part you should go from here because it is not because this is the shortest one, yeah, but it is because this is the only one rainbow pad that we have. So the other one is not rainbow pad because there is 13 and 13, the same one here.
So, Prof.
Understand?
Dafiq,
Yeah, yes,
enough if we only get one rainbow path only.
yes, this is one rainbow pad. So for RRC,
This graph we call rainbow
yeah, rainbow
anti-magic coloring.
anti-magic coloring, you just have one rainbow path. It is already enough for the necessary condition. Yeah.
Okay.
So if you have two rainbow path for all any one vertex to other vertex, then you have two REC. If you have three rainbow path, then you have three REC. And then finally, the general concept we call KREC. So that's a more complex problem, of course. Yeah.
Okay.
And if you have the shortest rainbow part, then you call strong RS.
Long.
Yeah. So if you have strong, but the strong mean for all two vertices, not only from X7, X6 to Y12. All vertices should be shortest path. Yeah. Then we call a strong rainbow. So there are a lot of type of the rainbow anti-magic coloring. It is well problem. So even 2 or 3, 4 students working on the same thing, then we can split the topic. First student working on the general rainbow anti-magic connection. Second one, 2 rainbow anti-magic connection number. Third one, strong rainbow anti-magic connection. There are a lot of things that we can do in the future. So, but it is already understandable. Yeah, okay.
Prof. Dafiq,
Yeah.
is strong rainbow anti-magic coloring, we need to consider shorter path for all any 2 path.
No, no. For only rainbow anti-magic coloring, we do not need to consider the shortest path for any path in this graph. But for the rainbow, for the strong rainbow anti-magic connection number or coloring, you should consider, you must consider the geodesic path, the shortest path of the rainbow path.
Okay.
Ya, so
Prof.
it's fantastic. Ini sudah ditemukan oleh kita, sudah menemukan, duduk 1 jam sudah menemukan, tinggal memformulasikan dalam sebuah teorema. Setelah ini saya akan bekerja dengan mahasiswa saya, nanti hasil formulasi pembuktian teoremanya akan saya kirim ke grup secepatnya.
Baik, Prof.
Alhamdulillah. Masya Allah, ini berkah Ramadan. Ya, padahal kita hanya punya yang tadi yang saya katakan, punya budi itu hanya ini. Ya, sometimes it is, could you, just close my share screen first. Sometimes it's quite easy to find out, but sometimes it will very hard. Yeah. So look at this one. It is published on 2020. It is undergraduate student. Yeah. Yeah. And then, some English is not so good. Yeah. But it's okay, no problem. They already find out the theorem for every integer. Then RAC of L3, n mean the cycle is 3 is n plus 2. That is the theorem that they found. And how they prove it, let this one lollipop, they call lollipop graph. Yeah, I'm not sure lollipop or tadpole or sometimes tadpole in there. With the vertex set, this one, yeah, exactly like Huber defined the vertex set in its set just before we got her presentation, and they got this one. And finally, they have what exactly? Yeah, they have, and this one is the H weight. So look at the H weight. Yeah, we should develop as well the H weight function. And then from this H weight function, then we can make sure we can convince that the number of distinct H weights attaining the base lower bound. Main here is n plus 2 colors. Then finally, we got it this proof, and then give some description or illustration about the existence of rainbow path here. Then finally, we already got the proof. Yeah. Okay. So what do you think? Is there any question? Yeah.
I have a question.
Yes, yes.
And if the path graph actually is an even or is an odd order, because when we eliminate one vertex, it doesn't affect anything.
For the path.
Yeah.
Yeah. Okay, okay. That's good then. So for order of path is any, but for order of cycle should be odd order. Yeah. Then we can generalize. Yeah. Okay. That's fantastic. Yeah. Is there any other? Okay. So the other ones, the whale that you already saw me as well. Okay. That's very good. Please continue. But by maybe 1 hours, I will send it to you. Yeah. After I ask my student to complete the proof, how to prove it, then maybe we can start to generalize also for the whale that Hubar already presented to us here. Okay. So is there any others our presentation today from of you? Just very brief description. Aisha, you already found something as well?
Yes.
Yeah,
Yeah.
just show me the graph, then we will finish that. Yeah. No need to discuss more. Just show me the graph. Yeah.
Hope everyone can
Ah,
see.
okay.
Actually, it's full graph.
Yeah. Understand. We
That's
already.
right.
Yes, definitely. Very good. Yeah. Yeah, very good. Just okay.
So basically, what the graph that I choose is a mesh graph, or we can call it as grid graph. And
Yeah,
sometimes we also can call it as a Cartesian product between paths.
yes.
Okay, this one is the example. So I try to level of this graph like 1, 2, 3. Oh, can see 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So and I got this as my the H weight of the graph, and it looks like doesn't have any problem. So after that, I do the bijection function.
Yeah, okay. Good.
Okay,
Keep
so
going.
this is the labeling for the vertex and also the H set. So x1, x12, x13, x14, x21, and until x34, because this one is 4 times 3, right? So the vertices is xij, where such that I is between 1 and n, and j is between 1 and m. So we have 2 dimension here, n times m. So that's why we got it 2. If it is square, because this one is a rectangle grid. So if it is square, we can say m here as n. All right. So the number of vertices is n times m, which is equal to nm. And then the H set of this graph is xij plus 1, where such that I is between 1 and n, and j is between 1 and n minus 1, which is union with the xij, xi plus 1, j. Such that I is between 1 and n minus 1 and j is between 1 and n. So the number of edges of this graph is, since it is a grid, or we can say it looks like matrices, we can say here we have n, column, row, yes, row, this one. So here we have n row. So that's why n minus 1, because for each row has n minus 1. So times with m, because we have m column, plus with n times n minus 1. Okay, equal to 2n minus n minus m. So that's all. How?
Yeah, very good. Yeah. It is.
Okay, continue.
Yes. But we already have a working paper as well, and still ongoing, yeah. So in grid, yeah. But let me check it first. If we can go with this graph, then we can go, yeah, and then we can develop also a lemma of theorem, yeah. But later after this, yeah. But yes, you didn't communicate with me, of course, before, then I should appreciate. Yeah, that's you already try best and you got it actually. So I understand that it is already right. Yeah, even if you extend for any order of PET with other order of PET, I believe it will be working. Yeah, but it's okay. It's okay. Let me finish the tadpole or lollipop graph first, and then I will send you some example how to develop a theorem or a lemma for future collaboration with us. Yeah, because in this situation, to start with the very serious working paper, we need to check the publication before, of course. If we already published by someone, then we do not need to continue with this one. Yeah, okay. Yeah. So thank you, Aisha. Yeah, silakan Aisha.
Add something, because the grid actually the fundamental, I can say is a fundamental for some of the graph. For example, actually from grid we can extend it into torus graph.
Yeah. If you can extend with the graph operation, that will be fantastic. Yeah, okay, very good. Yeah.
With the fundamental phrase. So
Yes,
making it easier
yeah.
for
Aisha, are you working on master or PhD program?
currently in master.
Yeah, very good, very good. So actually in the future,
Master in graph theory, Prof.
oh, already master in graph theory, now working on PhD student.
Not yet, not finished yet.
Not yet. Oh, okay, you are a lecturer?
Just
Yeah.
a student.
Okay, student. So already got it. Yeah, okay. So you are very good. Yeah. So if you have a basic construction, so you may start from the smaller graph and then you will blow up this graph into a bigger, and such a way that we get another specific family of graph, then it is fantastic then. Yeah. So it is actually our aims, yeah, in the future. How to find out the base graph. The base graph is very general one, yeah. If we operate with the other graph, the pattern still working on that new graph, resulting graph. That's very fantastic, yeah. So if we can try something like this, yeah, okay. Like in the previous tadpole, actually in tadpole or lollipop graph, my students said that we have combination of a cycle and also pet. Yeah, but this is not the real product of two graphs. Yeah, they attach only one vertex. Yeah, and finally we get some like properties. Yeah, for the cycle we have always odd order of the cycle. For the path we have even or any order of path. Thus, then we can have like a new graph in this thing that's a combination of two graphs. Yeah, but it's okay, no problem. So it's fantastic, and then I will send it to you by maybe 1 hour or 2 hours today, Sharifa, for the lollipop. Then we can enjoy and trying to find out the other ones, and then we'll check it whether it is already published or not in some way. Yeah, and then if it is already published, then we can find out the other one. Yeah, thank you, Sharifa. It is enough today.
Yes, enough for
Okay.
graph theory slot. We have another problem.
Yeah,
I didn't know that.
But for machine learning, we
yes.
only initiate to have some like informal discussion first. No need to have presentation. So it's okay. I'm really welcome to all of your colleges if we can have this discussion. Okay. Okay, thank you. This one I will. So you can continue with this link, Zoom link. It's okay. No problem. Yeah,
Wait, Prof. I need to ask.
Yes,
Aisha or Dr. Vitri, is it Zahari or Raida in the?
Yeah, ada. We are already here.
Okay, Prof. They are already in seminar room. Thank you, Dr. Vitri, Aisha, Sophia, and Kausar.
Thank you, Prof.
Thank you, Prof.
Assalamualaikum.
Waalaikumsalam. Prof. Prof. Dafiq.
Yes, I am here. Waalaikumsalam warahmatullahi wabarakatuh. Yes.
I interview first, Prof. We have here Zahari, master in computer science.
Computer science. Alhamdulillah.
Correction.
And,
Correction.
and PhD in cryptography.
So he's now working on cryptography. Okay, alhamdulillah.
Yes,
Yeah.
Degree in computer science, master in mathematical cryptography, and also PhD ongoing.
Yeah, okay.
And
Alhamdulillah.
another one is Raida.
Good afternoon, Prof.
Ya, alhamdulillah. Ibu Raida, alhamdulillah. Good afternoon. Yeah. Yeah. Okay. So only both of you?
No, we have another one. Zurita.
Okay.
Where is Zurita? Actually, her daughter is not very well. Get chicken pox, so she cannot come to work like me also. But me, I'm not very well. Okay.
Anis.
So we have three staff from InSpam actually.
Okay, let me start informal discussion first before sometime we are going to little bit further about our study. Yeah. So actually, I have two publication. It is in a good journal actually. Application of the labeling into cryptography. Yeah. The application of labeling. I'm waiting my staff to send to me, and then I will share to you about this one. Yeah. So actually, this is anti-magic labeling that's already discussed with Sharifa student just right now, and then we apply to cryptography. Yeah. So. Especially when we to have encryption or description from plain text into ciphertext and ciphertext into plain text, and then we are really effectively able to apply anti-magic labeling to what makes encryption data. But until now, we haven't made some coding, yeah, to have encryption decryption in the simulation process. That's I'm thinking, but let me show you maybe in 15 minutes about the paper. Yeah, it's already published. Yeah, already published. Yeah. Secondly, we are also applied our graph theory into machine learning in the computer science. So again, since I'm working on the graph and combinatorics, then we choose the research of interest, the special topic in artificial neural network, namely graph neural networks. Yeah, do you hear about this theory? Graph neural networks. Yeah. So graph neural networks, I just want to ask you again. So both of you familiar with machine learning?
Not familiar, not too familiar, but we are
Okay, okay.
with the
And then you are interested to go or to do a research on machine learning or in cryptography?
machine learning, Prof.
Oh, machine learning. Okay. Let me just give you a brief introduction. Sudanese. A brief introduction about the machine learning. Yeah. So, but this is in a graph. Yeah, in a graph. Plus, yeah. Okay. Okay.
I would
Yes.
like, me myself, I'm not really familiar with machine learning. But I know that my background is mathematics education, and my master is in applied mathematics. But currently I'm doing PhD in mathematics education. But somehow,
Oh, okay.
mathematics also already bridged into machine learning technique in order to analyze the data. So when I hear about Prof. Dafiq is able to discuss about this machine learning, so I'm interested to know whether we can share the knowledge, or like maybe you know which part of ML that can be used to analyze data for education.
All right. Okay. That's very good. Yeah. Luckily, also, I'm working on education, especially STEM education. I'm working on STEM education. So in which education's research of interest are you working?
Mathematics education, but currently my research, PhD research is to see whether there is a relation between mathematics education, achievement of student with security, information security awareness, something like that.
Okay. Yeah, okay. Let me show you something here. Yeah. Okay. So this is for machine learning. Yeah. Okay, yeah. Just a minute. Yeah. So I'm really happy if you can also have a joint research with us about education and machine learning, especially for digital literacy, yeah, artificial intelligence literacy in the students, because this is also a big challenge. Yeah, whether students are having already awareness about the existence of big data surrounding them. Yeah. Okay. Let me show you some machine learning that we already have it here. Yeah. Okay. Maybe this one is. Yeah. Okay. Okay. This one. Yeah. We have two presentations that we already presented in front of a conference last time. But I will show you something here which is very very big, general one, artificial intelligence. Yeah. So actually, the literacy in our school level is still lags about the artificial intelligence use, as well as machine learning use in the school level. So we have a project how to develop their literacy, especially meta literacy. Meta literacy combining information literacy and artificial intelligence literacy. So that's why we call meta literacy. So normally our educational research object is to develop the learning materials in a certain model or certain approach of education to develop or to improve their meta literacy of the student, solving some specific problem. For example, in STEM, for example, we have environmental problem, yeah, and students are trained to have a data and as well as to solve a problem based on the machine learning. That's in our case. So normally student, especially in master degree student in education, they involve a machine learning to have to solve a STEM problem. So do you know STEM? Yeah, science, technology, engineering, and mathematics. So this is a little bit different with the security, data security. Yeah, okay. Okay, now, so I believe this one is introduction. So in the main set actually domain, the artificial intelligence is the big domain, and the subset of the artificial intelligence is machine learning, and the below one is neural networks. And neural network, if we have only one what is hidden layer that we call just normal neural networks. But if we have more than one hidden layer, we call deep learning. So people sometimes talk about deep learning, machine learning, and also so on. Yeah. Okay. Well, so what is actually a machine learning, artificial intelligence? Is all that machine actually different with human being. So now we have human being, we have a machine learning, we have a machine. In machine learning, of course, machine learn from data. So data should be big enough, otherwise the machine couldn't learn properly. But for normal machine, conventional machine, they learn or they are working based on the instruction. So if you have a remote car, for example, toys, for example, you have a remoting that car, and the car toys can go aware or something like this. But in machine learning, they learn from a data. But human being learn from the experience. Okay, neural network now. So I believe I can give it to you as well. It is now from machine learning. We have three things: supervised machine learning, unsupervised machine learning, reinforcement machine learning. So when you're dealing with the student literacy or student higher order thinking skill, and you collect the data, is it numeric or not? If it is numeric, and then you will analyze that data, then you can use supervised machine learning, because it is only a regression, just regression. Yeah. But if it is not numeric, yeah, sometimes it is fall into binary choices like true and false. True and false. It is it could be categorized as supervised machine learning, but if not, it should be unsupervised machine learning. So there is a specific software of those kind of thing, and the other one is reinforcement machine learning. So I'm just asking you, in which type of data you will potentially collect in the future? It is numeric, or it is image, or it is what?
It's for education.
Yes, for education. So you are dealing with the student in the classroom. You analyze their higher order thinking skill, or what? You're dealing with the social community, social practitioners in education.
I'm dealing with the undergraduate students.
Yeah, just of course. So if you have undergraduate student, you will have a quantitative approach or a qualitative approach.
Quantitative approach. I will use
Next.
quantitative approach, but my question is whether when we use quantitative approach, is it enough for us to analyze using machine learning? Because
Yes, definitely we can. Yes, yeah. So I'll show you here. Yeah, okay. This is the software that we use it so far in machine learning. There is Python, there is R language, Scale language program, C++, Java, and MATLAB as well. And all of them can be used in analyzing the data from the education side of data, for example, from the student, because you are training, you are implementing a WASI experiment, for example, you split into two groups. The first group is, for example, a control class, and the second one is experiment class, and you got the data, whether this is ordinal data or interval data. It is good. Yeah. So very often, then I will share also to you some publication that we use MATLAB, use Python, use this one in already published in the good journal as well after this one. Yeah, and then I'll choose it this one. Yeah, okay. So no, yeah, okay, please.
analyze questionnaire item for using machine learning also. But
Sorry?
can we
Analyzing.
analyze the questionnaire result?
Yeah, definitely. So how big so if you're dealing with undergraduate, will you do experimental, was experiment research, or you will do like survey research? If it is survey, then you will have a lot of big numbers of respondent. Yeah. If it is more than 100, for example, it is enough to use a structural equation model, and then we analyze by using rapid manner, or using smart PLS, or using whatever. Yeah. So we have a lot of tools about this one. Yeah.
I'm aware that my SP intended me to use structural equation modeling.
Yes. That's very good. Yeah. Then
Is it this one part of machine learning?
no. Yeah. So in machine learning, there are at least training session, testing session, and validation session. In smart PLS, structural equation model, we didn't use it that. Yeah. We don't use that step. That's what flows. But in machine learning, we use 3 of this kind of process. Yeah.
We still can use the same data, but using the different process.
Yeah.
Like
Yeah. We can use the same data for simulation, but we need to know what is the objective of the analyzing process of this data. So do you know the interpolation or approximation, and then we do a regression in machine learning. or do you want to classify, yeah, doing a classification of the data, which one the for example, poor classification, which one fair classification, which one good classification, which one is distinction classification, for example. And machine learning, we can do classification like by using there is a tool, but it is also actually in the statistic. We know that about K-mean or forever, something like this. Yeah.
Okay, Prof.
Yeah. So sometimes if you can prepare some what the topic of your research, as well as the type of the data, maybe we can consider which what appropriate machine learning software that we can use it. Yeah. What do you think?
Okay. For the time being, what I've been thinking is to use the survey data because I'm collecting survey from undergraduate student, and I still don't know how to use the data using deep machine learning instead of
Yes.
the way of statistics using
Okay. Okay, that's very good. If you can give like the illustration of type of the data, then it is very clear for me to suggest to you in which manner or which objective that you can use machine learning to analyze the data. So your data from a questionnaire result,
Yes.
and then you have like Likert scale, something like 1 until to 5 or something like that.
Right, Prof. 5-point Likert scale from very disagree to very agree is the same.
Yeah, understand. That's actually okay. That's I understand. Yeah. So actually, if I can prepare and then I will show you something about this result from the machine learning. Yeah, but sometimes need a little bit to know about how to write the coding in Python or in MATLAB if you use machine learning. Some machine learning, actually we have like application like a rapid manner. So that is a part of machine learning as well. If you have a data, then we can try. Yeah. So are you in which years are you a PhD student? It is a final year or it is just a beginning?
Second year.
Second years. Okay. So tell me something. If you are willing to have a joint research with us, then tell us about like what is actually the topic of your research, and then what is the variable, what is of the type of a data, and then we can discuss a little bit more about the your data, your research activity. Then, yeah. Okay. Yes, definitely. So I already said to you that you have a lot of software there, and machine learning can do. But if I do not have illustration yet about the type of the data, then I cannot give you some suggestion which software that you can use it for the analyzing the data. Okay. Yeah. Okay. So, but I already said to Sharifa, at least I understand in what kind of research of interest that you are already working on right now. So the other one, Bapak, you are working on cryptography. So hopefully my student already sent me Sudanis. Di mana itu? Rainbow anti-magic coloring? Mana itu? That is strong. Yeah. Okay. I'll send you my two papers to Sharifah in a group of Rainbow Anti-Magic. Yeah, Sharifah, can you hear me? Because
Yes, yes.
yeah, so
Yes, I
please
get.
give to them. This is the application of what anti-magic coloring into what anti-magic labeling into cryptography. Yeah,
Cryptography. Okay.
yeah. Okay. So sorry, what is again your name, brother? What is again your name?
Hari, Prof.
Ari.
Hari.
Okay, Tohari. Okay, sorry. Yeah. Tohari. Okay, I already have it here. Stream case generation based on a graph labeling for strengthening visionary encryption. Do you what hear about these terms in cryptography? Stream case generation based on a graph labeling for strengthening visionary encryption. The first author is Professor Antonius Cahya Prihandoko. Is my friend from Faculty of Information Technology, and myself and Ika. Yeah. Okay. Hopefully, Sharifah already give it to them. Yeah, to Tahari. And the second one is myself on local super anti-magic total phase coloring and the application in developing a cyberblock chaining key. So do you hear this kind of terms in cryptography?
Oh no, I don't familiar with that.
You don't familiar? You see, like blockchaining key, it is part of the cryptography technique. Yeah. So actually, which kind of cryptography are you working on right now?
My field is public key crypto system.
Yeah, actually, public key crypto system. Yes, yes, it is actually. So you have a lot of technique when you are generating generate ciphertext. You have a lot of like visionary, blockchaining, and other. But that's what it is. All that system sometimes is very easy to revealed by the intruder. Yeah. Then we apply to the cryptography system by using anti-magic labeling of a graph. So this is already published, and then you can enjoy first. And then if you have a similarity with us and you have also interested, then we can start to have a joint research for the future. Yeah. So what do you think? Yeah. Okay. Sharifah, I believe that's our informal discussion first. What do you think, Sharifah? Then we will prepare sometime. Yeah, okay.
But for machine learning,
Yes.
focus for education, is it? Education
Working on education, then okay, we will focus on education. But if
no,
we
no, that what we discussed today. I see what
yeah, but we haven't started the serious discussion yet, but we just want to know in which machine learning side you will work on right now, and finally I can get some conclusion that she is working on education. She want to use a machine learning application to analyze her data collection. Am I right? Yeah. So, but we do not yet decided in which what objective, whether it is regression, just to know some relation or correlation or whatever. That's part of the statistic inferential, or it is classification or clustering. So if they want to cluster something, and then we need to have a machine learning. Yeah. If it is just like a regression or finding a correlation or finding to test the hypothesis, for example, the difference between one treatment to the other treatment by using independent sample t-test or paired sample t-test or whatever, I believe it is not really needing machine learning software. Yeah, that's but the Zahari working on cryptography, but he is still not familiar with my terms in my publication. Maybe you, Sharifah, please distribute to them, to Shahari especially, and I will find out for the ones sitting next to Sahari some paper on STEM education, and which is use machine learning. Yeah, and then I will also send to you. Okay.
And another prof, actually we have one staff in Spain who deal with graph network and graph neural network.
Oh,
She
very
also
good, very
deal
good.
with machine learning. She is Zurita, but
Yeah.
today she didn't join us.
He is already working on graph neural network.
She know about this. I think she
She know about it. Okay, okay. That's very good. Fantastic then.
she
Yeah.
when I inform but when I inform her that you do deal with neural network, and she said to me, oh, I do graph neural network.
Oh, very good. Fantastic. Then we can have a discussion. Yeah. So all of you are lecturers, yeah?
No. A research officer.
Research officer.
Research officer. Okay.
They need to do many research actually.
Yeah, no problems. So,
but because this is her job.
So clearly, honestly, that our cooperation for the long future or for the short future, our aim is to gain or to have a publication. Yeah, Sharifa, yeah. So this is our objective. So I'm not in position that I will make like training to your staff. it is not our duty, and so I actually give you some information and describe something to have a publication. So we are having reciprocal cooperation. So you also giving something to me, and I also giving something to you. Then we will have a good and nice cooperation for the future. And then I will visit your also university. You will visit my university in the short future. So inshallah, it will be barakah. Inshallah, yeah.
Thank you, bro.
Yeah, okay. Okay, I finished today, yeah, because this is already 40 minutes past 2. Alhamdulillah, insyaAllah. Semoga kita bisa jumpa lagi di masa-masa yang akan datang, insyaAllah. Ya, setelah hari raya. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
Yeah. So please make it a group again in machine learning, including cryptography, education, and as well as graph neural networks. You are welcome because it is part of our searching knowledge research. Yeah, okay. Thank you. Can I leave the meeting? Yes. Okay.
Yes. Selamat Hari Raya, Prof.
Selamat Hari Raya. Alhamdulillah. Eid Mubarak. Eid Mubarak.
Jumpa lagi after Raya. Okay, Zahari. Raida, bye-bye. Esok saya datang.
Okay.
Okay.
Okay. Assalamualaikum.
Okay.